place you want to think, you think and whatnot. I will set the paper in such a way you are going to solve it in something like uh, uh, something like 90 days, okay, or rather 45 minutes. I will set the paper for 90 minutes. The question paper will be for maximum marks of 60, but I will divide it by 2, so that 1 mark here and there that would have lost because of 30 marks, that will be good for you. So I just want to make sure that you are the beneficiary for all the exam. Okay. Please note, examination is meant to make sure that your mind becomes sharper. Because after some time, you have to make sure that uh, you have to stand on your own leg after the BTech program. So what remains with you is the mechanism of thinking and mechanism of okay. The, I will join you on the computer. Huh? Okay.
Okay, sir.
How do I log out on the mobile? Any idea? Just wait. Huh?
Yeah, other things, sir, you can try to join from your laptop, sir. There will switch option also.
Hmm? Let me see whether I can switch here itself. Just give me 5 minutes. I will join there. Can you hear? Am I audible?
Yes, sir.
Hello?
Yes, sir. Yes, sir. You are
Hmm.
audible, sir.
I will quickly start with the, okay. I'll quickly start with the some examples, and then you may be able to understand what I'm saying. So I'll write it on the vacuum tablet. Okay. Yeah, the paint is opening now. 1 minute. Today is 11th September. What I was telling you is that suppose you take x in L4. Okay. And suppose you define fx equal to summation I equal to 1 to n xi, say n to the power of minus 4 or something, say minus 4. Now the question can be, what is this f? So this x is in L4, and the conjugate of this 4 is 1 over 4 plus 1 over p prime equal to 1. Therefore, 1 over p prime equal to 1 minus 1 by 4. That is 3 by 4. No, 4 by 3. Right? So if this fellow is in, if this fellow n raised to minus 4, okay, this sequence, if it is in L of 4 by 3, then you can use Holder's inequality here. Okay. Then what you get is the mod of fx, okay, will be less than or equal to the norm of x in L4, and the norm of x, norm of this n raised to minus 4 in L4 by 3. Right? So this is a fixed number. So therefore, the norm of this f will be smaller than or equal to this, whatever this number is. Right? Now f is linear. Okay. And f satisfies this condition. Therefore, f belongs to, yeah, complete. F belongs to Quickly complete. It's a linear function on L4. Therefore, what is F? It is in the dual of L4, right? L4 star. Is it clear? Rishabh, is it clear?
Yes, sir.
Now, the point that you have to note here is you are asking about Holder's application of Holder's inequality, no? So this X is in
Yes, sir. Yes, sir.
L4, you have to make sure that this is in L3. So what you should do for solving this problem? Solving this problem, you have to make sure this is in L3. Sorry, L4 by 3. Will it be in L4 by 3 or not? You look at the summation or whatever it is. Okay? Now, do you know how to calculate whether this n by 4? What I'm saying is, let me solve it completely. This sequence n raised to minus 4, this is your an. I have to calculate an raised to 4 by 3. Correct? That will be n raised to minus 4 into 4 by 3 with a minus sign. That is nothing but n raised to minus 16 by 3. Now call this as some number. Okay, this is greater than 1. Therefore, summation an raised to p prime is finite. Therefore, this number n raised to minus 4, this sequence will be in L p prime 1 over p prime equal to 1 minus 1 by 4. Is it clear?
Yes, sir. I have one doubt, sir. How we can say n raised power minus 16 by 3 always greater than equal to 1?
No, no, no. I'm saying this. This one is this. What I'm saying is 16 by 3 is greater than 1.
Okay,
Okay.
okay, sir. Okay,
So
sir.
what you are using is summation n raised to minus p is finite if p is greater than 1. That is what I'm using. That's what is used.
Okay, sir. Okay.
Yeah.
Okay, sir. Clear. Yes,
But you
sir.
have
Sir,
to make
clear.
sure that this index is greater than 1. Don't worry about the minus,
Okay, sir. Okay, sir.
right? Or do you think it's a hard problem?
Sir,
Mhm.
unless our concept is not clear.
Tell me one thing, your concept should be made clear by whom? There are only two persons. One is me, another is your hard work.
Yes, sir. Yes, sir. Definitely, sir.
So if you are not able to solve this problem, either I am a bad teacher or you are not doing your homework.
No, sir. We are the bad
No,
students, sir.
no. What I am saying is, please understand, I am not saying whether you are a good teacher or you are not doing hard work. These are the only two things that can happen. That is all I am saying, nothing more.
Yes, sir. Understood, sir.
Yeah. So unnecessarily don't heat your mind. And you see, the thing is, how much time do you think you will need to solve this problem? Huh?
2 or 3 minutes, sir. Maximum.
That's what I'm saying. That's exactly what I'm saying. But I will be giving you something like 8 to 10, 8 minutes or 7 minutes for this question. Double the time, but
Okay.
like what I am trying to do. You see, the point is that you should know that you want to know something about F is. What is that you have to look at is the following thing. Okay, let me save this one and then send it to you. Okay, just 1 minute. I want to save this.
Okay, sir.
Uh, result saved. The point which I am trying to tell you is that if you have a linear operator t from say m to n a linear. M and n are linear, see, non-linear spaces. How do I show this T is continuous? That's one of the questions on which many people ask questions. For which what you should do is you calculate norm of Tx, okay, and then show, okay, after this, show that this norm of Tx is bounded by some constant k times norm x. And this fellow is independent of x. Then this will imply that norm of T is bounded by k. Yes or no? You know this or not? Okay? Then this will show you that T is bounded linear or continuous map from M to N. That is all, nothing more. Take an example, okay? Let us take M to be
Sir,
L2.
sir,
Go ahead.
if we show the bounded, then it will be continuous. Again, if we show the continuous, then it will be bounded. Both sided be
Sure,
true, yeah, only
sure,
one.
sure. That I have shown, no? 5 things are equivalent.
Yes, sir, yes, sir.
So this will imply and by imply AT is continuous. Both, huh? That I have done it. Shall we take an example? Would you like to look at an example?
Yes,
Okay.
sir.
Let us
One
take
short
M.
example, sir.
Let us take L201. You understand this, no? This is set of all functions which are square integrable. What is that, you know? Integral fg mod of this is bounded by norm f p norm g q 1 over p plus 1 over q equal to 1. Is it clear? This we know. Hold up. You define a map.
Yes, sir. Yes, sir.
Define a map T of fx equal to integral 0 to 1 x fx. Is it bounded? Will it exist? F is in L2, okay? So you have P equal to 2. So what is Q? Conjugate? 2, right? Half plus half is 1. Okay?
Yes.
Now, this is in L2. You show that this is in L2. This is in L2. Then this you can use this inequality. Then this integral exists. So let us calculate integral mod x squared. Everything is positive, dx. 0 to 1. Now that is nothing but x cubed by 3. Actually, between 0 and 1. So it will be equal to 1 by 3. That is finite. Therefore, this function x squared or x is in L2 0 1. Clear? So this is F, this is in L2, this is in L2, and therefore TFX exists. Correct? Now we want to show it is in say L2 square. So now let me look at T of Fx. Okay, mod of this. I take a bound on this. So what you get here,
Yes, sir.
this will be less than or equal to this norm f in L2 and norm of x squared. Okay, that in a 1 by 3. Okay, clear? By Holder's inequality. Now you square it. Then you get a square here. You get a square here. Integrate 0 to 1. Integrate 0 to 1. This is finite because this is constant. Therefore, T of T is a map from L2 to L2. Is it clear?
Yes, sir.
T is linear, obvious. Now this gives you that norm of T is bounded by that 1/3 or whatever it is. So it is bounded. Therefore, T belongs to T is continuous linear. This is what I am saying. What you have done is the theory. But these are the sort of problems which you should know how to solve it. But these are the applications. This same example, I'll come to it later. This operator tells you later that this has no eigenvalues. That is not the story with the finite dimensional case. Every linear operator will have an eigenvalue, real or complex. In this case, it may not have an eigenvalue. Clear? Want some more example?
Yes, sir. Yes, sir.
Okay. Now let's take C01. Okay, suppose I call it as M. With the supnarum. Supnarum is also written as L infinity norm. Now Xn converges to X in M if and only if Xn converges to X uniformly on M. That is why this norm is also called uniform norm. Okay? Let us take PR, set of all polynomials. Defined on 0, 1 with real coefficients. Okay? Every PR is continuous, no? Every polynomial is continuous. In fact, it is differentiable. Therefore, this PR will be a subset of C01. Okay? Not only subset, it's a linear subspace. Why? Because if you add two polynomials, you get another polynomial. Negative of a polynomial gives you the negative part of the a plus b is 0, the inverse of it. Zero polynomial gives you the zero element of this. Therefore, this becomes a subspace. Question now is it closed? Can you answer this question? Can you answer or you cannot answer? Or you want to think for a while? Shall I give a hint?
Yes, sir.
Weierstrass theorem. Bernstein polynomial, Weierstrass theorem. What does it say? Weierstrass theorem says that every continuous function is a uniform limit of Bernstein polynomials. Yes? You
Yes,
remember or
sir.
not? Right? Therefore, it is in the uniform convergence. And therefore, what did I tell you here? The uniform convergence is the norm convergence. Right? Therefore, if you take, for example, sin x, okay, you take sin x. Now, this can be uniformly approximated by Bernstein polynomials as n goes to infinity uniformly. Therefore, if this were to be closed, this is the limit point. God. This is a closed, if this sin x becomes a limit point of this polynomial. Okay. So there is a sequence from PNR, PR, which goes to sin x. If this is closed, then sin x should be in PR. So this implies sin x is in PR. If it is closed, please note if is important. If it is closed. Is sin x a polynomial? Is it a polynomial? Sin x is not a polynomial, right? It's any function. You can take any function and do the same thing here. So the limit point of PR is not in PR. So what should be PR? If it is closed, it should contain all its limit point. Since it has one limit point which is not in PR, therefore it is not closed. So it is not closed. Clear? Anything want to? Do you understand the how you should attempt a problem? अरे हाँ कहो ना कहो कुछ भी कहो.
Yes, sir.
Now, what is the basic thing here? If you don't know Weierstrass theorem, then you are gone. Clear? So what many people do is, when giving this sort of questions in the examination, which is not done in the class, I have done it in the class now, they say hint, use Weierstrass theorem. After giving the hint also, if you don't do it, then it's a very difficult case. See, in this example where I am taking t of fx equal to x into fx, why only x? Huh? I could have taken x squared also. I could have taken any function g which is in L2 also. So these are the sort of the way how a question can be modified, and you should not get you should not get this something like psyched by these sort of questions which you see or don't see it. That is the point which I am saying. Okay. Do you want this piece of paper? I'll save it then. I'll save this and send it to you, okay?
Okay, sir. Thank you, sir.
So now do you understand, do you see now how you should prepare and whatnot? There should be more mental work than physical work. That's why I said in the class, how do you really solve a problem? That's why I sent you one problem sheet with solutions. याद है क्या?
Yes,
Yes,
sir.
sir.
So when you don't know the solution, read that, understand it. Huh? ठीक है?
Okay, sir.
Hmm. Just 1 minute. Going back to the Google Meet. This. I'm just stopping the sharing. Just 1 minute. Huh?
Excuse me, sir.
Yeah.
Sir, in the assignment or the problem sheet with solution you have given, so there was a question regarding fifth question, sir, where you asked for like you have given a ball and then you asked to prove it open and then so there is B bar. So that B bar is something complement or something.
No, B bar is the closure.
Okay,
B
sir.
bar is the
Thank you.
closure. That is take all the limit point. That is the surface of the ball will be in that. ठीक है. B bar is the closure. Huh?
Yes, sir.
Am I audible, Rishabh?
Yes, sir.
You see, the U bar means norm of x less than or equal to 1. U means somebody asked a question about the bar. B01 means norm x less than 1, strictly less than 1. B01 bar means norm of x less than or equal to 1. That means the closure contains the surface also. Whereas the open ball will not contain the surface. What is that surface? It is nothing but set of all limit points. Clear? Is that the
Yes,
question?
sir. Yes, sir. Thank you, sir.
Okay. This thing should be done in metric spaces, no? Okay, all right, don't worry. We will learn it now. The time is almost up. All right. So I will leave the call now. Enjoy yourself. Do well. If you have problems, if you want, I will come on the Zoom meeting on Sunday sometime. You let me know what time you want asking Richard. Then you can ask any questions you want. Is it okay? Or are you busy on Sunday?
Yes, sir.
Whatever time.
Sir,
Chat.
I will ask to everyone. I
Either it is Sunday or Saturday. Okay, both days are holidays.
I think everyone is there, sir. If okay, then we can take one discussion on.
Okay. All right. Bye bye.
Yes, sir. Yes, sir.